This video is the probability, the addition rule, and complements part 2. We're going to start with example 5 from the PowerPoint, FCC students. Consider the following information about a group of 130 FCC students. We've broken them up into gender and then right-handed versus left-handed. This, I believe we had this table in a previous example on another video. If one person is randomly selected from the group, what is the probability that this student is female or left-handed? Okay, so we can, Okay, one way to do this is use the formula, which is to find the probability of a female, find the probability of a left-handed, add them together, and subtract the overlap. So let's see where we got these numbers from. A female, there are 71 females out of 130, plus left-handers, there are 25 total left-handers out of 130. But if you'll look, this 71 and the 25 both had 13 included, so we need to subtract that overlap. So subtract those that are both female and left-handed. So female and left-handed is 13, so we're going to subtract that out. We get 83 over 130, which is 0.638. Another way to look at this is to say, okay, we want female or left-handed. So I can circle all the females, then circle all the left-handed. Now notice I didn't circle the ends, the totals. I'm just looking at the numbers that make up the totals. And then I can see, okay, well there's 58, 13, and 12. So 58 plus 13 plus 12 is the same as 83 out of 130. So you can also use the table and circle everyone that's a female, everyone that's left-handed, and then you just make sure when we did it that way, we didn't add the 13 twice. Okay, so that's just another way to approach it. Okay, so let's look at compute the probability for selecting a male or a right-handed student. So you could do male, which is 59 out of 130, plus right-handed, which is 105 out of 130, and then subtract the overlap, and it looks like they overlap right here at 47. So you see down here 59 over 130 plus 105 over 130 minus the overlap of 47 over 130, which is 117. The other way you could do it is you could circle all the males and circle all the right-handed, and you can see that you have 58 plus 47 would have been the overlap, so we don't add that twice, and 12, and you'll get 117 over 130. And 117 over 130 is 0.9. 0.9. Alright, so this one says the table below shows the number of survey subjects who have received and not received a speeding ticket in the last year and the color of their car. The color in regards to whether it's red or not red. Find the probability that a randomly chosen person has a red car or got a speeding ticket. So if we use the formula, we're going to do the red car total, find the probability of the red car, and then find the probability that they got a speeding ticket and subtract any overlap. So let's see, red car, probability of a red car is 150 out of 665. The probability of a speeding ticket is 60 out of 665, and the probability that they have a red car and got a speeding ticket, the overlap is 15 out of 665. When you add and subtract that, you get 195 over 665, which is 0.293. Or you could say, all right, red cars, there's 15 and 135. And then speeding tickets, there's 15 and 45. So you would add your 15, making sure not to add it twice, plus your 135, plus your 45. And you end up with your 195 over 65, which is 0.293. All right, next up is complements. Complements can be explained this way. If there's a 30% chance of rain today, then there's a 70% chance that it will not rain today. In regards to rain, there are only two possible events. These two events, rain and no rain, are complements. So a complement of an event is when the event doesn't occur. And so this is the formula. This is the notation. P and then of A and then C for complement, and you kind of write it like an exponent, is equal to 1 minus the probability of A. So the probability of A not happening is equal to 1 minus the probability that it does happen. So if you think of it up here, 1 minus 30% is 70%. Another way to write it, and I write it like this because I think it's a little bit easier to draw a line, a bar above the A rather than to write a C. This also means complement of A as well. Notice the formula is the same. It's just showing you a different notation. You might end up seeing both. I use this one more than I use this one right here. So I like to use that one. You can also, another way to do it rather than subtracting from 1 is just add all the ways that A can't happen and divide that by the total. So if you pull a random card, what's the probability that it is not a heart? So we can do 1 minus the probability that it is a heart. So that's 1 minus, there are, now we have 1/4 here, but to show you how we got that, that's 13 out of 52, which reduces to 1/4. Either way, you're going to get, I believe you'll get 36 out of 52, which is 3/4 or 0.75. All right, next one. A multiple choice question has 5 answers, and exactly one of them is correct. If you were to guess, what's the probability of not getting a correct answer? Okay, so we would find the probability that you would get a correct answer and subtract that from 1. So 1 minus the probability of getting it correct is 1 minus, there's one correct answer out of 5. When you subtract, you get 4/5, which is 0.8. Or you could just say, well, how many, if there are 5 answers, how many are not correct? There are 4 answers that are not correct, and just put that over 5. So either way will work. According to the FCC website, female students make up 57% of the fall 2014 student body. If one student is randomly selected, what is the probability that the student is not female? So why don't you pause the video and try this one. Okay, hopefully you had a chance to work it. Let's see what the answer is. The probability of not female is the same as 1 minus the probability that it is female. The probability that it is female is the same as this percentage, 57%, except we're going to write it as a proportion. So 1 minus 0.57 will equal 0.43. So the probability that the student is not female is 0.43. And that's it for the addition rule and complements. Let me know if you have questions.